And I think we are live. Yes, probably. Yes, over here. Hmm. Okay. एक बार टेस्ट बोल लेते हैं.
Test. Check.
बस मेरी तो आ रही है. आ रही है. ओके. डन है जी. Okay, we can start.
All right.
Cool. So, I think in the last stream we briefly went over what schemas were. And after that, I did a brief stream with revision to what schemas were. And I think, oh no, yes, over here. Mm, mhm. And ये दिखाने दे मेरे को पूरी ही स्क्रीन दिखानी पड़ेगी ताकि मैं वो notebooks में भी I can switch. Okay, so we can just go through schemas once more real quick, and then we can cover scope today.
Mm-hmm.
And what is scope? What is XForm? XForm should not be that tough
Yeah,
because it's pretty
I
small.
think we already went through it.
XForm common API is also pretty small, so we can do
And then
that.
the light.
And then lights. I think this should be our goal for today, like
Yeah,
these three or
perfect.
four things. So let's start off with schemas once more, real quick. So, what schemas are? Schemas are basically an is an object that provides structured API for authoring and retrieving data from prims or properties. So schema basically gives the meaning to prims in OpenUSD. That is, what is this element? What capabilities does it have? Schemas define the data models and optional API for encoding and interchanging 3D and non-3D concepts through OpenUSD. We'll explore the different types of schemas, their characteristics, and how they enable the creation of sophisticated virtual worlds and digital twins. What are schemas? They serve as the blueprint that author and retrieve data, like attribute and relationship that govern behaviors of elements in USD scene. Okay. Each prim in a scene is an element. I think we can use this. Oh no. Yeah, bro, start reading.
All right. So each frame in a scene is an element that implicitly contains the properties and fallback values of the typed schema that's telling the prim what it is. For example, the radius attribute of the sphere schema is defined as double radius equal to 1, meaning that all sphere prims have a radius represented by a double precision floating point number with a value of 1 by default. In a similar manner, if we are assigning a variable in JavaScript, C++, we need to define the data type of that variable. That's what we are doing over here. Our variable is radius, and the data type over here is double, right? And moving on, schemas are primarily data models with documented rules on how the data should be interpreted.
Okay, wait. I think we should go through this analogy first so that we have a better idea of what schemas are. Think of schema as a pre-printed apartment lease or a recipe card. The blueprint analogy, housing application. Imagine that you're a landlord. Instead of writing new contract from scratch for every single tenant, you have a stack of standard one-bedroom lease forms. Okay. The schema blank form. This is a blueprint. The form has specific boxes already labeled: rent, amount, move-in date, and pet policy. The prim, the tenant. When a new person, a prim moves in, you hand them that specific form. By simply giving the one bedroom lease form, they implicitly know the rules. Okay, so that is okay, okay. Prim is the tenant and blank form is the schema. Okay.
Mm-hmm.
Attribute and fallback values, the default rules. The form that might have a rule printed at the bottom unless otherwise specified. The security deposit is $1,000. Okay. This is exactly like sphere radius equal to 1. Even if you don't write anything in the radius box, the computer assumes it's 1 because the form, the schema says so. Okay. Identity connection. In OpenUSD, prim doesn't know what it is until you give it a schema. Without a schema, the prim is just a generic thing, a blank piece of paper. With a schema, you stamp sphere on the paper. The result, suddenly that paper magically gains a radius property and a center property because those are part of the sphere schema. Okay. Efficiency. You don't have to tell every single sphere in your scene that it needs a radius. The schema handles that paperwork for you. Consistency. Every tool like USDV or Omniverse knows exactly what the sphere is supposed to look like because they all read the same blueprint. Okay, cool. Schemas are primarily data models with documented rules on how the data should be interpreted. While schemas define the structure and rules, they do not necessarily include the implementation of behavior. Cool. For example, USD physics schema does not come with physics engine. Developers may provide behaviors in the schema API, but this is not a requirement. Okay, now I get it. There is a trend towards codeless schemas for easier distribution. That schemas might become more lightweight. For yeah, I wanted to get this in detail. What does this mean? Okay, we have to look at the difference between data, what something is, and behavior, what it does. Codeless schema, the blueprint only approach. Traditionally, a schema often came with a bunch of C++ or Python code attached to it that told the computer exactly how to handle that object. Codeless means the schema is now just a simple text description of the data, like a list of variables without any logic built in. Data modeling versus behavior implementation. Data modeling defines a structure. Example: a car has four wheels and a color. Behavior implementation defining the action. Example: when I press go, calculate the friction of the tires and move the car. Okay, data modeling versus behavior implementation. Okay, the dumb analogy: Lego brick versus the video game character. Old way, heavyweight. Imagine buying a digital Lego brick that comes with a 100-page manual and its own specific software that you must install just to see it. It's a hard way to share with friends because they might not have the right software. Codeless way, lightweight. Lego brick is the shape and the color. You can give it to anyone. It just works because it's so simple. Okay, the subsystem part. You don't need to the brick how to fall behavior instead of the floor. The runtime ecosystem physics engine knows the anything dropped on it should stop. Okay. Easier distribution. It is much easier to send a file from Maya to Unreal Engine or on NVIDIA Omniverse if the file doesn't have a bunch of hidden code that might crash on one of these programs. Okay, in short, schemas are becoming the label on the box rather than the machine inside the box. Okay, got it. Actual behavior enforcement can be managed by subsystems within the runtime ecosystems. This allows okay. IAS and API schemas. We talked about this little briefly. Okay, do you want to read?
Yeah. So ISA schema or is
Is
a schema,
yeah.
also known as typed schemas or prem schemas, essentially tell a prem what it is. Because of this, each prem can only subscribe to one is a schema at a time. We use the type name metadata to assign is a schema to a prem, and is a schemas are derived from core class that is USD type. The base class for all the type schemas, which is why we here is a schema referred to as type schema. Now, schemas can either be concrete, that is instantiable, or abstract, non-concrete, serve as a base class. We refer to a schema as concrete when the schema can be instantiated as prim in the USDC. As we see the USD geom mesh and USD geom scope, concrete schemas provide both a name and the type name and the schema definition. Meanwhile, abstract or non-concrete schemas provide a name but no type name in the schema definition. This enables them to serve as a base class for related sets of concrete schemas. The way USD geom point base serve as a base class for geometric objects that contain points like meshes, USD geom mesh, or basic curves, USD geom basic curves. Okay, so basically, like it's like TypeScript
Mm-hmm.
with more type definitions and more stringent rules for defining a schema.
Yeah.
The only thing you have to focus on is what is this concrete and abstract ones.
Yeah, I'm asking it to explain us with examples.
Mm.
Okay, think of is a schema as the core identity or species of an object in your 3D world. Core identity or species. To make this simple, let's use the animal kingdom as an analogy. The one identity rule. The text says each prim can only have one as a schema at a time. The analogy. A living creature can be a dog or it can be a cat, but it cannot be both. Ah, okay, okay. Both at the same exact time. It has one primary species that defines what it is at its core. If you tell a prim it's a sphere, it cannot also be a mesh. Bro, what's exactly a mesh? I don't know what's a
Mesh is basically a grid, I think. This is,
material.
yeah.
But okay,
It's mesh, like you can
me-
have a color mesh, you can have something that, you remember we did a IPYNV notebook demo in which we wrapped the cubes into
into
colors
mesh, yeah, material
and then
binding.
wrap them into different colors accordingly. Like some of them were green, some of them were red. So this is where mesh comes in at this point. Like I think it helps us to simulate what kind of fabric materials the robots might be working with eventually.
Mm-hmm.
For example, let's say we are trying to make a robot learn sieving.
Mm-hmm.
So and that material would be a mesh material, maybe silk or something, and that material can have the properties of silk or something so that we can emulate it properly in our omniverse environment.
Mm-hmm. Okay. The one identity rule. Okay. Concrete schemas, the real animals. These are schemas that you can actually spawn or build in your scene. They have a type name, a specific ID the computer recognizes. Okay. Can you read
That-
this and
yeah, sure.
explain?
Hmm. Concrete schemas, the real animals. These are the schemas that you can actually spawn or build in your scene. They have a type name, a specific ID the computer recognizes. So analogy, a golden retriever, you can go out and get a golden retriever. It exists in the physical world. In USD geo mesh and scope are concrete. You can type stage or define my mesh and a real object. Oh, okay, okay. So it's basically saying that there are some kind of objects that are gonna exist all the time.
Mm-hmm.
For example, having a mesh material or having the geom scope thing that is like basically geometric models or something, maybe a triangle, a cube, a sphere. All these objects already exist in the real world. So they will have a different concrete schema. Why? Because they will be used by other developers, other engineers for creating the same object from base, and then maybe adding other schemas or other uh, how would I say models over that, and maybe integrating it with other metrics in a way. So this is what concrete schemas are. Moving on, then we have
Oh, so
abstract.
they are already defined, right?
Yeah.
Like
So like
its properties are
retriever,
already defined.
yeah. So like if you go with the golden retriever analogy, you have a lot of dogs out over there, and they will have different kind. Like you have Pomerian, you have Labrador, and then you have golden retriever, right?
Hmm.
So in that scenario, if you want a dog, you would just go and get a dog. But now, and then you can basically apply that dog, and then you can maybe color that dog with something, and you can apply the same analogy to a mesh. You get a mesh, you color the mesh, you trim the mesh, you can do whatever you want, but it's going to be concrete. Like it will have certain properties that are going to exist all the time. Those things are going to be generalized, and developers cannot like define. Maybe they can tweak something. Maybe for example, they can cut the nails of the dog,
Hmm.
trim the edges out or something. And then we have abstract schemas, the family groups. These schemas don't have a type name and cannot be built directly. They only exist to pass down DNA to other objects. The analogy, mammal. You cannot go to a pet store and buy a generic mammal. You have to buy a dog, a cat, or a hamster. However, all those animals share mammal traits like having fur and being warm blooded. In USD, if we use USD geom point based, it's an abstract schema. You can't make a point based prim, but it provides the DNA like vortex position for things like meshes and curves. Hmm. I think can you click on the USD geom point based so that we can get a more. Yeah. Oh, is it? What the hell?
It's just pointing over here to the same thing. But we can search it over here and here.
Search is in the so go to the search. There's a search menu on the top. Oh yeah, there we go.
Hmm.
Excellent. This is with an example.
Foundational schema for any geometric primitive that is defined by a set of points such as meshes, curves, or point clouds. It centralizes the management of spatial data points, motion data, velocities, acceleration, and surface orientation. Based on USD geom point-based class reference, the primary attributes you will interact with are points, velocities, normals, and acceleration. Okay. Okay. Okay, I get it a little bit.
Mm-hmm. I think we will get to know more about it as we dive into the hands-on
Mm-hmm.
on how we can use each of these
Yeah.
API schemas. In addition to is a schema, we have API schemas. API schemas are similar to as a schema, except it does it does not specify a type
Specify a
name.
type name.
Since it does not have a type name, they are considered to be non-concrete.
Mhm.
API schemas are typically named with suffix API in their C++
So
or
what's the
Python.
difference between non-concrete and abstract then?
Hmm, interesting
Because
question. You can actually build it a physical golden retriever. So I think non-concrete and abstract. I think both of them are same, right? Non-concrete and abstract schemas are also non-concrete because like if you go up, it says
Mhm.
over here, go up. No, no, in this in API schemas. Yeah, go up. Schema serves blah blah blah. Where does it say? It did say it somewhere. Wait, let me take a look. Go up, go up.
That's it.
It says it did set somewhere. No, no, it did set somewhere. So anything that any API or any function that has API is basically API schema, and we can differentiate them by looking at them. Then we can define them as like basically non-concrete schemas since they do not have a type name. It says over here USD physics dot rigid body API. This is gonna be a non-concrete schema.
Okay, they're the same thing. Oh, I see. Got it. Non-applied or applied schemas. Okay, I can read this again. In addition to ISO schema, we have API schemas. API schemas are similar to ISO schema, except it does not specify type name. Since it does not have a type name, they are considered to be non-concrete. API schemas are typically named with suffix API in their C++ or Python class names, such as USD Shared Connectable API. Properties that belong to an API schema are namespaced with schemas based and camel cased, for example. Yeah, exactly. What is camel cased? I always get confused.
Camel case, like basically what it says over there. Camel with C capital.
So,
So in camel case, the second
oh,
word
letter,
letter.
word of the letter is okay, like this.
Yeah.
Got it. It will create an attribute named physics velocity. USD physics dot rigid body API dot create velocity attribute. Okay, API schemas can be classified as non-applied or applied schemas, and single apply or multiple apply, where single apply API schemas are applied to only a single instance of a prim, and multiple apply scheme API schemas can be applied multiple times to the same prim with different instance names. Single apply or multiple apply where single apply API schemas. I don't understand this statement.
Oh,
Mm-hmm.
non-applied. This is like waterproofing tool that stays on the workbench. You can use tool to check if the robot is waterproof. But non-applied is basically validation functions. Remember, we were doing our IPYNB notebook, and we first created a prim, and then we defined it as a cube or something, and then we were trying to validate it. Right? Is this prim valid or something? Right?
Mm-hmm.
Those would be considered non-applied. And then if we apply something, let's say applying a mesh, applying something related to mesh color, or or maybe wrapping the object into some kind of material using an API, that would be considered as applied schema.
Mm-hmm. Mm-hmm.
Single apply mass weight skill robot only has one weight. You wouldn't give it weight A equal to 10 kilo and weight B equal to 5 kilo. The same time you apply at once and you are done. USG example, USG physics rigid body API. An object is either a physics object or it isn't. Multiple applied stackable skill.
And single apply or multiple apply, where single apply APIs are applied to only single instance of the prim, and the multiple apply schema times to the same prim with different instance names. Okay, this shit is complicated, bro.
Dude, you know what? That's what I'm saying. Like if we go ahead and try some of the hands-on notebook, we will get to know more. You can just ask Gemini to give us some snippets of the code with elaborate example. I think that will help us a lot.
Applied versus non-applied. When you stick it on the roof of your ropes, blah blah blah. Okay, it has given us some code. Oh, look at this.
Mm-hmm.
It gave us two code snippets about this. So I understand this part, okay. Now API schema is adding skills. The sphere is still a sphere, but now it has a physics skill. Physics API equals to USD physics dot rigid body API dot apply sphere prim dot get prim. Physics API dot create velocity attribute set GF vec 3f. Okay, I don't know what that is. Check if prim has the specific API. This sphere can now participate in physics simulations. Okay, multiple apply API schema, stacking skills. The collection API is multiple apply schema. We can add, we can apply it twice to the same object as long as we give each instance a unique name. Applied collection, physics rigid body API, collection API shiny
Basically, API
objects.
and everything are non-schemas. Like basically API schemas are non-concrete.
Hmm. Okay. Let's add some metadata to our sphere to store information that doesn't change during animation. Asset author. So that's the metadata it has set. If you print the stage context output, you will see the type name. Mm-hmm. Hmm. Okay, I think I get it now. Sphere or mesh confirming is a schema is active.
Like sphere is always defined. Like you won't be able to change the properties of a sphere. It's spherical. Uh, it would have a certain dimensions and all those things. But the radius that is gone that can be changeable because it's a variable out over there.
Mm-hmm. Okay, we can read the rest of it. God
Over here, I
damn.
think if you go down, I can give a more example, like in the working with Python. You see, we
Mm-hmm.
have the registry.find schema info. That can be a non-applied schema over here, I would say, because it's not applying anything. It's just getting trying to get the information out. Can
Mm-hmm.
you ask Gemini if this is a non-applied schema or not?
Which one?
This thing,
Which?
the USD.schema registry.find schema info. This must be a non-applied schema based on my understanding.
Bro, that is not a schema, it's just a function that it retrieves the type of schema.
If, no, but it would come under non-applied schema. Like non-applied schema is basically something that is not applied
We can
on
work with schemas using following methods. It's just, I think.
ask it once.
No, see, it's a tool,
Hmm.
bro. Tool, a function.
Okay, okay. Hmm. Yeah, that's what I wanted to verify. I think. Yeah.
Okay, we can move ahead. What does this mean? Queryable with has API method.
Like you can query schemas with does it has API?
Hmm.
It's I think it would be basically checking if there if any API exists for that schema or not. Yeah. See.
Okay, over here.
Hmm.
I see. Okay, it's a official library. USD schema registry. Okay,
Tisungwa.
is a schema. Sphere equals to USD. Okay, we can just define schema for representing geometric objects such as meshes, cameras, and curves, as mentioned above. Meshes, cameras, and curves, as mentioned above, it also includes schemas for transformations, visibility, and other common properties. Import related classes define a sphere in the stage sphere equals to USD geom dot sphere define. Okay, get and set the attribute.
Get set methods to set something and get something.
Yeah.
USD geom is a defined schema, I would say over here. Like is a typed schema since USD geom has a sphere. So anything that we would call inside using USD geom would come under is a typed schema
Mm-hmm.
because yeah because like it typed schema because it would have a radius with a certain data type that exists
Mm-hmm.
on a prem.
Okay. USD Lux defines schemas and for representing light sources in a scene. It includes schemas such as shared lights, disk lights, and distant lights, which were discussed in the lesson on USD lights. We didn't have a lesson on USD lights, right?
No, we are gonna have it
In
in next
upcoming
episode.
modules. These schemas bring properties relevant to each light type. Example radius for USD Lux disk light. These attributes in combination with the attributes defined by Light's API, Light API schema, intensity, blah blah blah. Okay. Let me run this in the thing real quick. True. So what are they doing here? This is easy from Pixar USD Lux. Define a disk light in the stage. USD Lux disk light dot define attribute names that are a part of disk light schema. DL attribute name disk light dot attribute names. Get and set radius and intensity of the light. Mhm. USD physics rigid body API. So similarly, API schemas with Python is a schema USD geosphere, USD lux disk light. API schemas is USD physics rigid body. Okay, apply the USD physics rigid body API on the cube prim. Okay, this is an example of how API schemas can be applied to prims to add specific properties that govern behavior, such as adding rigid body capability to object hierarchy. Schemas in OpenUSD serve as templates for defining prims. It's worth noting there are actually two distinct types of schemas. There's a schema, API schema, work alongside a flexible and extensible system for building complex scenes in. Okay. Schemas are a complex topic, but when leveraged correctly, they can simplify the creation and interchange of USD scenes. We'll cover the schemas again, including custom schemas in future lessons. Okay, I think we have
Mm-hmm.
completed schemas again.
Yeah.
Yeah, it is
Scope.
pretty complicated, but
Yeah. But I think as we move on and get
yeah,
more
we'll get
hands on it.
understand more. Yeah. What I understand right now is that there are two types of schemas, is a schema and an API schema. Is a schema is the schema that is used to define a prim, like if it is a cube or a sphere or a cuboid or whatever. And an API schema is used to basically give the properties to that is a schema or the prim that the is a schema as defined. So, for example, over here, the USD physics rigid body API schema is basically giving the physics properties to the cube or the sphere uh, to make that prim act or behave in a certain manner in that scene description.
Mm-hmm.
Yeah,
Scope.
let's go. Let me see if somebody is watching or not. Nobody. Nobody. We are past our prime.
Mm.
We peaked at 13 views, concurrent 13 views.
I think we are also doing it right now, like at different time. We used to do it
Yeah.
around 11, right? So that's why
Mm-hmm.
maybe.
All right, let's get started with scope. Read it, bro.
Scope. Okay. All right. Understanding scope is important as they help in organizing and managing complexity in large scale 3D scenes. What is a scope? In OpenUSD, a scope is a special type of prem that is used primarily as a grouping mechanism in the scene graph. It does not represent any geometry or renderable content itself, but act as a container for organizing other prims. Okay, so scope is not something that we are trying to render, but more like a container. Like if we can, I can give it an analogy of if you are trying to build a website, then you put div inside the website like a container, and then you put other assets and other elements inside it. And think of scope as an empty folder on your computer where you organize files. Similarly, scope helps in structuring and organizing prims within a USD scene.
Okay, wait.
Pretty
In
straightforward.
OpenUSD, a scope is special type of prim that is used primarily as a grouping mechanism in the scene graph. Okay, it does not represent any geometry renderable content itself, but acts as a container for organizing other prims. Okay, think of a scope as an empty folder on your computer where you organize files. Similarly, scope helps in structuring and organizing prims within a USD scene. As an empty folder in your computer where you organize files. Similarly, scopes help in structuring and organizing prims within a USD scene. Okay, let's play the video. Mm-hmm. I see.
Scope cannot be transformed, used as a lightweight organizational containers, will evaluate all transformable child prims correctly from within the scope prim and down the hierarchy. Hmm. Simplifies scene management, make it easier for teams to navigate, modify, and render scenes.
One second, let me. Hmm.
plays a crucial role in organization and management of complex 3D scenes. Serve as a container for other prems.
Oh, it's raining.
It's raining. What's going on over here? It's not raining, but it might drizzle more, I think.
Mm-hmm. Gulf
Gulf of Mexico.
is sending water. Okay, bro, read this.
How does it work? Wait, give me a minute. Yeah, there we go. Scope prims are used to create logical grouping of related prims, which can be particularly useful in complex scenes with numerous elements. For example, a scope might be used to group all prims related to material, animation, or geometry. The key feature of scope is that they cannot be transformed, which promotes their usage as lightweight organizational containers. All transformable child prims, such as geometry prims or XPOMs, will be evaluated from within the scope prim and down the hierarchy. The organization aids in simplifying scene management, making it easier for teams to navigate, modify, and render scenes. Scope might be used to group all prims. Okay. Well, instead of materials, animations, or geometry.
What does this mean, bro? So a key feature of scopes is that they cannot be transformed. Transformed into what? What does
Which
that
wait,
mean over here?
wait, it says which promotes their usage as wait. What? So I think transform is you cannot put any transform means like so if you use geometry frames or XForm, we can translate the object, right? Basically move the object on a certain
Mm-hmm.
axis. But these scopes cannot do that. I would say like they so if a scope is defined, it's gonna be rigid and it's gonna be standardized at this point. I think that's what it means over here because it gives us an example that such as geometry prims or X forms, and in our earlier hands-on notebook experiments, we saw that we did use XForms and geometry prims to create some kind of translation for an
Mm-hmm.
object. For example, one of the thing we did was we created two objects. That was a cube and another was a sphere, and then we put a coordinate of phi so that the cube gets translated on the x-axis.
Mm-hmm.
So, but but since it was a prim, they were transferable. But if you use scope, you won't be able to do that, I'm assuming. So like basically it's saying that
Wait,
okay, I got it. I got it. Assume this is the scope, right?
wait, I'm not able to see you. 1 second.
You
Okay. Yeah.
right? Assume this is a scope.
Mm-hmm.
And in this scope you have this object. So
Scope
you
is a
can try.
group, bro. Scope is a grouping
Yes,
prim.
that's what I'm saying.
Okay.
Assume, just
Okay.
assume. And then you are putting this object that is a transformable object
Mm-hmm.
to it, right? You
Mm-hmm.
can translate it inside the scope, but you
Mm-hmm.
cannot translate the whole scope or
Oh.
so basically, for example, now you have two scopes.
Mm-hmm.
Now you say, hey, I want this scope to be over here or over here. You
Mm-hmm.
cannot do that, right? This scope stays over here only.
Mm-hmm.
But so any object inside that scope can be transformable, but not the scope.
Mm-hmm.
So this is what I think high level and explanation would be for this. But I think we will get to know more about as we dig in more.
Okay. I think I get partially a
Yeah.
little bit, but okay.
The
Let's
this organization agent simplifying scenes.
the key a key feature of scopes is that they cannot be transformed, which promotes their usage as lightweight organizational containers. All transformable child prims such as geometry prims or X forms will be evaluated correctly from within the scope prim such and down the hierarchy. This organization aids in simplifying scene management and making it easier for teams to navigate, modify, and render scenes. Okay, let me dumb this down a little bit.
The hell.
The hell?
See,
Yeah, yeah, I know for storage. Okay.
form is like a wagon that you move things around. Scope is just a container designed to keep your room.
While an X form is like a wagon that can move things around, scope is just a container designed to keep your room, the scene tidy. The analogy, the labeled boxes. Imagine you are packing up your house. You have a lot of different items, toys, kitchen supplies box, the scope, the plain box. You grab the box and written kitchen on the side. You put up all the spoons, cups, plates. Okay, the box has no wheels. It just sits there. Its only job is to keep the kitchen stuff from getting messed up with the toys. Because the box doesn't have any wheels, it cannot be transformed. You accidentally drive the whole kitchen box to the backyard. If you want to move a spoon, you reach inside the box and move the spoon itself. Okay. Oh, I understand. Now I understand. The child prims the items inside, even though the box is stationary, the items inside, like a toy car with wheels, can still move around perfectly fine. They aren't stuck just because the box is. Got it. I got it. Okay, working with Python. Used to define a new scope at a specific. Oh, do we have the. Oh, yes, we have. We do have the IPYNB notebook for this. Understanding a scope is important as they help in organizing and managing complexity in large scale 3D scenes. In OpenUSD, a scope is a type of. Okay, we already read this. Scope prims are used to create logical grouping related prim, which can be particularly useful in complex scenes with numerous elements. For example, scope might be used to group all the prims related to material, animation, or geometry. A key feature of scope is that cannot be transformed, which promotes their use as lightweight organizational containers or transformable. Child prims, such as geometry prims or X forms, will be evaluated correctly from within the scope prim and down the hierarchy. I get this now. This organization aids in simplifying scene management and making it easier for teams to navigate, modify, and render scenes working with Python. When working with scope in USD using Python, a couple functions are particularly useful. usdgeom.scope.define. Scope dot so everything is usdgeom, and
Yeah.
then usdgeom.scope.define, and then
Like
what
since
was
they're defining, I think typed schemas, that's what they
uh-huh.
are gonna be.
Okay.
Geom.
This command is generic, but it's useful to confirm that a prim type is a scope. Prim's type is a scope ensuring correct usage in script. Prim is a USD geom dot scope, and then I think that would print true or something, right?
Yeah.
Okay, now examples. Define a scope. Scope is grouping primitives and does not have transformability. It cannot be used to organize libraries with a large number of entry points. It also is the best to group actors and environments under partitioning scopes. Besides navigating, it's easy for a user to deactivate all actors or environments by deactivating the root scope. We can define scope using usdgeom.scope.define. Okay, got it. What does this mean? It can be used to organize libraries with large numbers of entry points.
Where is it?
This.
Group is does not. It can be used to organize libraries with large number of entry points, but it is also best to group actors and environment under libraries with large number of entry points. So I think maybe we can group the entry points
Mm-hmm.
in the same scope.
Yeah.
For example, let's say you're trying to pull in a library from Sphere, a library from Mesh, a library from something else that is defined, and then you can scope them under a single scope, let's say XYZ scope that you have created.
Mm-hmm.
So, and then you can pick up that scope and apply it to anywhere, I would assume. And it says it is also best to group actors in environment.
Master switches for complex scenes. With large number of entry points, imagine you have digital library containing 5,000 different 3D plans. If you just list them all in one long scroll, you'll never find anything. The fix you use scope called trees, another called bushes, and another called flowers, entry points. Starting path. This just means starting path to find an object. Instead of 5,000 messy paths, you have three clean folders to look into. I see. What the bro? Bro, turn off your notifications. That
Oh my bad.
ting, it just hurt my brain.
My bad. Let me
Oh
do
my
this.
god, bro, that was so loud.
Oh,
Bro, what the fuck?
wait. It's already on silent. Oh, my MacBook. It's my freaking MacBook.
Bro,
The
one more
sound.
time.
Alright, I think it should now. No, do anything.
Ugh, damn. Wow. Okay, it just. Bro. Okay, read this. I think I'm getting it a little bit. So basically, scopes, I understand this. Large number of entry points.
Oh,
Oh, okay. I get this now.
mm-hmm. What is it?
Basically, what this means is, for example, if you have like a lot of prims, for like
Mhm.
trees and bushes and flowers. You can basically scope them into like three folders in that hierarchy.
Mhm.
So all the trees will be in the tree folder, all the bushes will be in the bushes folder, all the flowers will be in the flower folder. And
What?
then
Okay, so you're saying that all the thing that I said was correct, or was it kind of incorrect?
what were you saying?
I said that if you can basically scope multiple libraries into a single scope and then package it and push it somewhere or reuse it.
I don't think the libraries is those
Well, it's what it
libraries.
says, right? It says over right over there.
Large number of entry
Can be
points.
used to
It can be.
organize libraries with large number of entry points.
I don't think it's talking about these libraries over here.
I think
It,
wait,
because if you read this digital, it's talking about digital library containing 5,000 different 3D plants.
okay, so yeah, that's what I'm saying. Like any library,
I think
mix of
library,
libraries.
what it means over here is basically like a directory which has all the prim data for
Oh, I see. Yeah, I see. Makes sense.
multiple plants and bushes.
Makes sense. Makes sense. What happened? What I do? What are they doing?
What?
What are they doing? It gets
Brain rot.
brain rot. No shit. Oh, crazy.
Screen. Screen. iPad kids. No, but they're good. They have like limited time.
What? Where are they going? They have limited time. What do you
No, no,
mean?
no, no. Their
Uh,
parents have set the time limits on the apps, so they
oh,
only
okay.
they only get like limited.
Hmm. Makes
Yeah.
sense, bro. You're ready for tomorrow's party.
Hmm?
Ready for tomorrow's. When is the event?
It's some stadium in Orlando.
Ah,
Yeah. Yeah, I am excited. I like Punjabi music.
nice.
Okay.
Crazy.
So, okay, I understand this now. I think we should run this in the IPYNB.
Perfect, perfect. Let's run it.
Oh, we already have it over here. Example one, define a scope. So, what they're doing over here. Oh, this
Finding
is
the
the
file
thing.
create with the stage, and then they have to
Oh,
find
what?
find X form. I think you have to run the first one and then the
Yeah,
second one.
I did. Ooh, okay. Assets scope.usda, so it's creating a new stage. World equals to USD geom. Xform.define stage world num a prims. What does this mean?
Those are like variables, dude. Nothing much.
No, no, but why? I know they are
You
variables, but
on a
why?
photo, go down, you will see it.
Oh, my bad, my bad, my bad. Okay. To organizational scopes, non-transformable grouping prims, a scope, uscgeom.scope.define, stage world.get path, append path. Okay, so this is how they're like defining the scope.
Hey, can you turn on the scope for the second one and rerun it again?
Turn on.
Yeah, go to the last second line.
Okay. This one.
Yeah, true, true.
But where did it wait?
So based on my understanding, we have two for loops. One of them is for cube, and the other one is for cube, and it did broke it somewhere.
Oh, because now there is no like for the loop. Now there is no scope
What?
because
Oh
we
wait, no. I think it's because we have already generated that file. You have to delete that file. Yeah, you have to delete the file that you just generated in the assets.
What is that file?
Go to assets. Yeah, delete all of them.
Okay. And should I do true now?
Yeah, let's do true, and then we'll see. I think it should not populate sphere. Oh wait, you broke again?
Yeah, but for some reason it's working for.
Oh,
Thank
I
you,
think you
bro.
have to restart it from the scratch, like first.
Oh, it's fine. Perks of
What happened?
being at home.
Oh, coffee.
Tea.
Tea. Oh my God,
Oh no, wait, I think it's coffee.
it's coffee.
Yeah, it's
No,
coffee.
you not take coffee post 5 p.m. Otherwise, you won't
What's
be
it?
able to sleep.
I will sleep just fine, bro. I don't smoke anymore, so I will just, you know, sleep just fine.
That's fine, but scientifically speaking.
Bro, we are still live on the stream, bro.
Alright, let's go.
Bro, something is going wrong for some reason. I don't get it.
Yeah, let me send the link.
It's failing to define the
No,
stage.
go to the first one. I think you're not running it from the starting.
No, but I
Yeah.
already ran it, bro. See?
No, it's saying that scope.usd are not found because I think, okay, let's delete all the files and rerun the whole one again. Yeah. Okay, go up. Yeah, now
Let me put this for okay, it's already false.
yeah, yeah.
Same thing.
Okay. I think we have to just add a file scope.usd or generate the scope.usd file that we might be missing now. So we are missing the scope.usd file.
No, but it's failing to define the prim for some reason.
Where is the prim sphere A? Wait. Of course, A scope.append. Go down. Error in because we are missing. Is it because we are missing the file?
Oh, I think I know what I messed up.
Hmm.
Mm, No, I don't think I messed up.
Because I think should we cover from? Should we restart the whole notebook and rerun all the cells?
No, but it's still gonna be deleted, right? If there's a file that we were not supposed to delete was deleted.
Hmm. We can load the file from somewhere, right? We can just copy the file and create it.
Yeah, but
Go to
where?
log.
Wait, copy. This is the directory. hmm What is this that we're doing? Scene description blueprints. Scene description blueprints. Bro, I don't know what to do.
Wait, go back to learn OpenUSD where from where we loaded this. Where
Yeah,
did you loaded this?
yeah.
And in there we should have assets somewhere.
Yeah, but I
Let's ask
think,
AI.
bro, what should I ask? Yeah.
Help us find the asset file.
What the fuck is wrong?
Hmm. Dude, Gemini is gonna help us. Actually.
Okay, let's see if it could. There is no assets folder inside that schema description blueprint directory. I think that gets generated once you run the thing, but I don't know. It cannot find it, bro.
Let me take a look now. Why the hell are we not able to find it? You loaded it from the OpenUSD, right? Like this repo.
Yeah, learn OpenUSD.
Mm, Git clone. Clone.
Nope, Gemini cannot find it either.
Maybe time to pull in the big guns. Test fixtures. Is it over here? It should be somewhere over here. Let me ask GitHub Copilot. Find me. What was the file name? Scene.usda, right?
I don't remember. Or wait, don't do that. Wait. Um, bro, the slash assets folder gets generated once we run that IPYNB block, I guess.
Oh.
Yeah. So I don't think you'll be able to find it anywhere. But okay, wait. I think I know what the issue is. We're gonna be fine. Mhm. Okay.
Did you? Were you able to make it work? Perfect. Back again.
Oh, wait. I think I know what to do. How do we restart this kernel? Where do we click to restart this kernel? Oh, here.
Where?
Restart kernel. Restart this frickin' kernel, brody.
From the stat and motherfucker.
Okay, I think we're back. Yes, sir. But for some reason, our thing has not appeared this time. Bro, what's going on? Okay, anyway, we can just focus on the code now. I think that's a different issue. So,
Okay.
two organizational scopes, non-transformable grouping prims. A scope, USD geom scope, define stage, world.get path, append path, A scope. B scope, USD geom dot scope, define stage, world.get path, append path, B scope. Populate the scopes with some geometry for A in range, nums, prims. Okay, 2. So that's where the for loop was ran.
Mm-hmm.
And sphere equals to USD geom dot sphere define thing. Okay. Okay, now it's fine. See,
What was the issue? Because we are missing a file.
because no, so we always need to restart the kernel because once we run this,
Now, let's rerun it. But this time, let's make it true so that we can also see the spears.
okay,
Wait,
restart
wait. First,
kernel.
wait. First, set the active to true over there. A
No,
scope dot get.
no, I know, but like first we need to restart the kernel, bro.
Okay. And then do true. So let's see what happens. Is it gonna run there? Whoa!
Oh, oh,
AI.
okay.
So I think yeah, I did understood the code completely now. This is what I was trying to do and trying to understand. So now we have what we have over here. We have two for loops. One with the if we add the
Sphere.
number of prims, no, we can have more prims. If we reduce the number of prims, we will have less prims. And then we have a
Mm-hmm.
for loop in which we are defining and appending the path of the sphere until we reach our set number of prims that we are trying to form. And then once we have those prims, what we are trying to do, we are trying to use the xform common api and use the set translate function over here to basically move the object in like place the objects in a certain manner. That's why we have a into 2.5. If we do
Mm-hmm.
not put a over here, then it's gone the prem is going to render on it over and over at the same place rather than rendering alongside the model.
Okay, now I
That
understand. I added bscope dot get prim set active false, so it removed the cubes.
yeah.
So it's
and
just
and,
the
and if you
spheres
want to
now.
say, we can also change the values of our x-axis and y-axis where we are translating it. So you can change 2.5 to 3 in the above, not over here in the sphere, like 3 or 4, and then
What will
the
happen?
it's going to increase the distance between each of them.
Let's do 7.
Okay.
What?
Now you have to
Restart.
Yeah.
Yeah, okay.
Bam. There we go. And let's play more. If we do 10, we will have 10 spheres at the same distance. So if we change the number of A primes to 10 in the above, like
Ah, you're right, you're right. Let's do
uh,
20, bro. Let's go big.
like,
Okay,
don't go.
kernel.
No, first you have to restart and clear the thing out first. Yeah. Now let's do 10.
Oh, wait. Oh, wait, my bad, my bad.
Wait from starting. Let's do training again.
Yes, 20. You see?
Oh, nice. Can we zoom in into that somehow? Is it possible to zoom in? No, no, like through the render.
I don't think so. I think we can, what we can do is,
What if we add another coordinate? Wait. Let's do two and then add another coordinate. Let's do
like,
5 on
like an
y-axis.
additional coordinate.
Yeah, let's change it from 0 to 5. Yeah, no, no, not additional coordinate. We can only
Oh,
have three axes. The
yeah,
additional coordinate would be like you're basically going into the fourth dimension now.
yeah. Time.
Yeah. And
Okay. I
okay,
don't know
wait.
what it did though.
It
I
should
don't know what
have
I don't know what the 5 did.
reduce. Wait, let's reduce the number to 3 so that we can observe it and restart the kernel properly. I
Damn,
should have
bro.
been
Yeah,
do
why
it
do we
on
need to do?
why are you doing it on Z axis? Try to do it on Y axis instead on Z axis.
Which
Wait,
one?
like over here instead of 5, over here do 0, and then in the middle do 5, and then it should probably like have some kind of linear array or something. No, bullshit.
No, it's all same.
Hmm. I don't know why it should render on top of each other somehow, but I don't know.
Mm-hmm.
Maybe we have to do something out over here. Oh, I know. I think let's do negative. Let's do negative 5. Let's do negative 5.
It doesn't do anything, bro.
Still not doing thing that we were trying to expect. I wonder why. Oh, I know why. Wait. Add a into over there maybe. Add
Where? Oh,
yeah.
over here.
Yeah, because we are trying to do it on the same. So let's add a. Yeah,
So it'll do it
now
on
it.
all three of them.
Yeah, I think so.
Yes,
There,
sir.
there we
I
go.
think it
There we
did it.
go. Woo. We have our interplanetary model ready.
Ready for the demo for A16Z. Please,
Yes,
if you're
sir.
watching, we have applied. Please. 1 million. Change our
1
lives.
million. There's this shit happening.
Bro, we can do it. We can do it. Okay, I think I understand how to define the scope and yeah. USD geom.sphere dot define. Cool. Key takeaways. Okay, we are done with scope.
Mm-hmm.
Scope RIMs in OpenUSD play a crucial role in organizational and management of complex 3D scenes. Its primary function is to serve as container for other prims, helping maintain clarity and structure in large projects. Okay. The only thing that I'm a little
Skeptical, confused.
confused, yeah, USD geom.scope.define stage world.get path. So this is giving it the path for our
World,
container, which is, yeah, this one.
yeah, the prem.
Okay. And then append path for a scope. A scope is the thing that we are defining over here.
Yeah.
Okay. Excuse me.
You are fused.
Hmm. Okay. Uh, can you? Okay. I have a quick doubt that I want to get resolved. What is the difference between the world container and the stage? Is anybody watching us? Oh, there was people. People just come and go for some reason.
Yeah.
Some people watched it for a while, but uh,
Maybe one of them was Tiger Dubai, the one and only our angel investor.
an advisor, financial advisor. What's up, Mickey?
Yeah.
You wanna come say hi to people who are watching? Come here. Say hi.
Hey, Mickey.
Say hi. Why are you running? Where are you running? Where are you running?
He's kind of, shy, I would say.
He is not shy.
He's not shy.
He's
I
not
think
shy.
his first time in front of camera. Maybe that's why he may be
Are you
shy.
shy? Are you shy? Are you shy? Come say hi. Tell them what. Okay, what did you learn at school today? Bro, people are watching you doing all that stuff. You know that, right? Look at that. People are watching.
That's fine.
Cutie. Okay. What? But you have to come here and tell them. You can't just, blabber from there. Be careful. You'll hurt yourself. Can you take this? Yeah. Yeah, yeah. I know. Be careful, bro. You're gonna spill it. Okay. Okay, that is a great question that touches on difference between the file, the stage, and the object inside that file, the prims. Think of it like the difference between the physical theater building and the stage floor inside it. Physical theater building and the stage floor inside it. The stage, creating a stage is a container for the file itself, the analogy, the theater building. Mm-hmm. It manages the entire environment, it holds the timeline frame rate, blah blah blah. Okay. The world container, the wooden stage floor built inside the theater. Okay. Got it. Got it. Got it. Got it. So def X form world, def scope A scope, def scope B scope. I understood the code, bro, completely.
I see. Key
Nice.
takeaways. Key takeaways. Scope prims in OpenUSD play a crucial role in organization and management of complex 3D scenes. And its primary function is to serve as a container for other prims, as we saw, and we did a couple of experiments as well to see how the components render over there,
Mm-hmm.
or how the prims render in the container,
Mm-hmm.
and help maintain clarity and structure in large objects.
Mm-hmm. Okay. So we can move to X form now, I think.
Yes, sir. Time for X form.
X form and X form common API. Okay, they're not that big, so it should be quick as well.
Yeah.
Oh,
And universal scene description. X form plays a key role in defining the spatial transformation of objects in a scene. What is an X form? In OpenUSD, an X form is a type of prim that stores transformation such as translation, rotation, and scaling, which apply to its child prims. This makes XForm a powerful tool for grouping and manipulating the spatial arrangement of objects in a 3D scene. XForm stands for transform, reflecting its role in transforming the place in which its children reside.
mhm. Okay, wait. In universal theme description, X form plays a key role in defining the spatial transformation of objects in scene. And what is an X form? In OpenUSD, an X form is a type of prim. So X form is a prim as well that stores transformation data such as translation, rotation, and scaling. Yeah, I've read this like a million times now,
Yeah,
which apply to its child prims. This makes X forms a powerful tool for grouping and manipulating the spatial arrangements of objects in 3D scene. XForm stands for transform, reflecting its role in transforming the space in which its children reside. Okay, let's see what this is. Are you able to hear this?
no, no, nothing.
Okay, so watch it on your end at the same time, I guess.
Mm. I think I would just go through whatever
Okay.
you're seeing. Yeah, because it basically dictates all those things, right?
Oh, yeah. Okay. So don't speak then, because I'll hear you and the video both. Yeah. XForm. I want to hear this one more time. Okay, wait. Did you see this? Unmute yourself, bro.
Which one?
Did you see this video?
Yeah, good XFOM operation or on all those things.
Okay. So basically, when we do USD geom.xform, oh, we have the thing over here as well. So, oh, wait. There's a separate section for xform common API also. Oh,
Yeah. So XFOM is different and the common API is going to be different, I think.
okay. So, in xform, so whenever we do USD geom.xform.define stage, comma path, it's basically defining the stage as an xform type.
Mm-hmm.
Okay. And retrieves the order of transformation operation, which is crucial for understanding how multiple transformations are combined. Different orders can yield different results, so understanding XFOM order is important. Okay, got it. So XFOM prims allow for hierarchical transformations, meaning that transformations applied to a parent XFOM affects all its children prims. This is essential in complex scenes where multiple objects need to move or scale relative to the parent. Typical use cases include animating characters or robotic arms where different parts are children of an XFOM prim, or arranging furniture in architectural visualization where all items in the room might be scaled or rotated together. Got it. USD geom xform dot define stage dot path stage comma path used to define an XFOM prim as a specified path on a given stage. So is this defining the stage as XFOM or is this defining a prim on the stage?
So you're defining a prim in XFOM,
Yeah, but
and then you're connecting it with the stage. So first you define the stage. You remember how we do how in the notebooks how the workflow looks like. First you define the stage. Once you have
yeah,
defined the
this is the stage, right? Like stage
yeah,
is
and
USD
then
dot
you define a
stage.
prim. Then you define a prim inside that stage, and that prim is gonna be the XFOM prim.
Okay,
That
okay, this is the
prim can
world.
yeah.
Mm-hmm. Got it.
Yeah.
Okay, example one, USD geom and XFOM. USD geom defines the 3D graphics related prim and property schemas that together form a basis of for interchanging geometry between digital content creation tools. 3D graphics related prim and property schemas define that. What does this mean? USD Geom defines the 3D graphics related prim. What does this mean? 3D graphics related prim.
You remember we did created a prim on three axis, that is three dimensions,
Uh-huh.
right? So you can USD has a property that you can create a prim on three dimensions, not on single
Oh,
dimensions, but
like
on
this
three.
one.
Yeah. And then
Stay.
you can use the XFOM Common API to do
Hmm.
more things. So that means that prim is able to take three parameters. That is a three-dimensional prim. It is a not
Mm-hmm.
a two-dimensional prim. It is not a one-dimensional prim. It is a three-dimensional prim at the same
Mm-hmm.
point.
Mm-hmm. Okay. Let together form a basis for interchanging geometry between digital content creation tools in graphic pipelines. Some things to know about USD Geom. All classes in USD Geom inherit from USD Geom Imageable, whose intent is to capture any prim type that might want to be rendered or visualized. Okay, all geometry prims are directly transformable. Encapsulates USD Geom. USD geomix encapsulates the schema for a prim that is transformable. Okay. And then USD geom xform is a concrete prim schema for transform, which is transformable and can transform other child prim as group. Let's run this and see what happens. From L learn openusd.utils.helper functions import create new stage. Mhm. So this is what you have been doing, right? This is the
Yeah.
most basic shit that we have been
Yeah.
doing in all the
Creating
modules.
prim based on XFORM. So XFORM allows us to do a lot of operations, as
Mm-hmm.
you have seen earlier in our other notebooks that we have been working on with.
Mm-hmm. Explain the usage of USD geom. Okay. Mm-hmm. If it is like an invisible ghost, might exist in math, but it won't show up in the final picture. Think of USD Geom as the physical laws and blueprints for everything you can actually see in the 3D world. While the core of USD handles the paperwork, the files, and the layers, USD Geom is the specific department that handles geometry. It defines the rules for how things look, where they sit, and how they are shaped. The analogy, the construction site. Imagine you are building the digital city, USD Geom, the architect's handbook. This is the master manual that defines what a wall, a floor, column. Okay. The visible rule. Okay, so imageable, USD Geom imageable, the visible rule. In the handbook, there is a section for things that can be seen. If the object is imageable, it means the camera can see it. If it's not, it's like an invisible code that might exist in math, but it won't show in the USD. The movable rule. The part of the handbook says this object has the right to be moved. Any object with this X-formable DNA can be slid into the floor, across the floor, blah blah blah. Okay, so I understand what USD Geom is for now.
Mm-hmm.
It's basically for USD Geom imageable. It will be Like it's gonna render using USD geomeasurable, and for USD geomix it's gonna be able to move across. Like it can be defined as any movement related property of any prim.
Mm-hmm.
Common tools in the USD geom kits: perfect ball, piece of clay molded by hand, complex shapes like character cards or terrains. Okay, USD geom mesh. Invisible group folders, putting a group of objects together so you can move them all at once. USD geomex form. Okay, so that's why this is USD geom.x form. Okay, we can move to the. Okay, you can read key takeaways and then we can move to XForm Common API.
Okay. So now we have explored the XForm uh, prims are what. Sorry, now we have explored what XForm prims are and how they function within the USD framework. We have seen how XForm prims are essential for defining and managing spatial transformation in a scene, making them indispensable for any 3D content creation workflow.
Yep, got it. Let's go. We have done three things out of the five that we decided to do. So this is the fourth one. XForm Common API. Okay, so this is a little longer than
Okay. What
XForm
is
Common. Yeah.
Common API? XForm Common API is a non-applied schema. See, it says
Mm-hmm.
API, that's why it's a non-applied schema.
Mm-hmm.
And earlier we had XForm, so we had everything predefined over there.
Mm-hmm.
And as a non-applied API schema of the OpenUSD framework, today we are diving into the API to understand its utility in the 3D content creation pipeline. The API facilitates the authoring and retrieval of a common set of operation with a single translation, rotation scale, and pivot that is generally compatible with import and export into many tools,
Mm-hmm.
designed to simplify the interchange of these transformation. Okay, so basically we are importing and exporting
Okay, wait. I
mm,
think I might have to stop the stream now because
single translation
what? We can do one more stream in like, are you?
or because why? Like, do you want to stop or how you?
Yeah, they wanna. I
Probably
need to take them
probably around after dinner. Yeah,
after what?
we can do after dinner, like around 9:30, 10.
Yeah, okay. We can do that.
All right. Okay. So
Cool.
stop.
And then we can complete XForm Common API and lights, and then we
Yeah.
can do the what do you say,
Quiz.
quiz
Quiz.
for all five paths.
Yep. All together.
Yeah, all together, or we could do separately. Uh,
No, we will do
we
all together. It will be much fun. We can take like 30 questions, and then I think
yeah
it's gonna cover because X farm is really small. The most of the
yeah
things that we have is in scope and X farm common API.
yeah. Okay,
Probably, yeah. Okay. All right, guys. It was fun. Let's see you back in probably 5 hours. Oh, sorry,
5 hours.
six,
Yeah,
4 hours. Like around 10:30 p.m.
cool.
Adios, amigos.
Ended. ठीक है